speed at which that ball is traveling in the x direction, it's going to travel that same speed the whole time until it hits the ground. In the y direction, it'll be changing. 8, we went over a lot, and in my CAP problems, and the third one, I just talked about this clarification. But you have to break down the component of the velocity of the person relative to the ground equal to two actions, the throw plus the run. And if it's the velocity of the ball, both of these are ball relative to ground, ball relative to Leica, then it's just the throw. Because R is only running, and they're both running. Ball's running, Leica's running. So the only thing that matters with that velocity of the ball is the throw, which is said to be 10 meters per second relative to Leica. You find this angle. There are many ways to do that. When you have a defined triangle that is 86.6, 50 tangent of theta equals 86.6 over 50. Everybody know inverse tangent on your calculator? That's how I get theta there. So then you take 10 meters per second, like I started over there, times cosine of theta for the x component. And you'll get 5. Next for b, we go back to these equations. We plug in 5 for t. And we wonder what this is in the x. Well, if that's 5, and this was negative 4, the answer is 1. 4, 9. That's the only choice that works out. However, the velocity component of the y matters to the next problem of how long the ball is in the air. It follows the parabolic path like I explained a couple minutes ago. And its maximum velocity, its maximum position will be when its velocity equals 0. What is this? Plus AT. How long is the ball in the air? The only thing that matters is y. 8.66 plus negative 9.8 equals 0. Solve for t. Negative 8.66 over negative 9.8 is approximately 0.9. That is how much time has elapsed when it gets to its maximum point. And I showed how that maximum point is the velocity at the point where it's 1/2 of its path. The time is spent over here, 1/2 the time is spent over there. So you times this 0.9, whatever that is, by 2, and we get 1.8-ish. That's the answer. And the last question is about forces. Where's this? This was an extra credit question, right? Yeah.
Yeah. That's just the You're Wanda Rousey and all those impressions.
Just circles. You jump on these. So she pushes this way. The velocity is negative something. It's just a v. Why does it say the forces are equal?
Because every force is equal but opposite reaction. Remember, you got the truck and the Prius, and the Prius is chilling, and then like someone truck says, "I hate Priuses," hits it. Like the force that the Prius is going to exert on the truck is going to be equal but opposite of what the force of the truck is exerting on the Prius. Newton's third law.